Guys, now we're going to be looking at scientific notation. Now, for those who haven't heard of this word before, scientific notation is when we're trying to reduce the way we write certain numbers. So I've got over here, it could be in the form a times 10 to the power of k or negative a times 10 to the power of k. So the common part with those two terms, guys, is 10 to the power of k, isn't it? So it's like a 10 to the power of something. So if it's like a really big number, say 45,000 or something like that, it's not really big, but it's got a lot of zeros at the end, then we're trying to reduce it by writing 10 to the power of something and trying to reduce the way we write the number. If it's a really small number, say for example like 0.0059, we also want to reduce that because we don't want to be writing too many zeros and too many numbers that make it so long. So that's one of the examples of when we use scientific notation and how it becomes quite handy. Now, the key point to the scientific notation form is the a. That number next to the 10 to the power of whatever must always be between 1 and 10. And k is an integer. So this power that the 10 has, the k, must be an integer. So it can't be like a decimal or a fraction or something like that. It has to be a whole number. It can be negative, it can be positive, but it just must be whole. Now, the other thing I just said, a must be in between 1 and 10. Okay, so it can be 1, but it can't be 10. The thing is that it's a single digit number that a has. So not a single digit, but the term, the whole. So for example, I'll show you such as this one. See how 2.1? I've made a as 2.1. See how 2.1 is in between 1 and 10? So yes, it can be written in scientific notation. Or 1.24. See how that's between 1 and 10? So that is also can be written in scientific notation. And see here, guys, the powers of 10 are integers, aren't they? They're whole numbers. It can be negative or positive, but it's whole numbers. So these are examples. Another example would be this one, 4.05. So 4.05 is between 1 and 10. And again, the power 8 is an integer. So yes, it can be written in scientific notation. Okay, so that's pretty much it. So let's have a look at the questions, guys. Which of the following numbers are in scientific notation? Now, it just must satisfy two important features I've explained in the beginning. The number in front of this 10 must be between 1 and 10, and the power must be an integer. And this one satisfies both, so yes, it is in scientific notation. Now B, 4.2. Okay, 4.2 is first of all in between 1 and 10, so yes, that satisfies one of them. But look at the power, guys. It's 2.5. It's not an integer, so therefore it's not in scientific notation. Now C, 22. 22, is that in between 1 and 10? No, it's not. So we can say it's not in scientific notation. Now D, okay, first of all, is 0.5 in between 1 and 10? No, it's less than 1, so this one is not in scientific notation. Now, negative 2.6. See, negative 2.6. We don't really worry about the negative. We just disregard the negative. We only focus on the number itself. So 2.6 is in between 1 and 10, isn't it? So that one satisfies the first condition. And 5, it's an integer, isn't it? So therefore, this one is in scientific notation. So guys, when you determine this one, you don't have to worry about the negative in front, just the number itself. F, okay, 6 is in between 1 and 10, and the power 5 is also an integer, so it is in scientific notation. G, 3.0 is in between 1 and 10, but this one here, this is 5 to the power of 2, but we always want 10 to the power of something. So this one is not in scientific notation. That 5, we can't have that with scientific notation. Okay, question 2, fill in the blanks. Alright, so see here, kind of look at the pattern, guys. So we're going to be filling in these missing spots, but have a look, they give us some examples. See, 10,000. How many zeros are here? There's 1, 2, 3, 4. So it's 10 to the power 4 basically. Yeah, so 10 to the power 4, if you expand it out, it becomes 10,000. See here, 1,000 is 10 times 10 times 10, isn't it? Which is 10 cubed. And you can also find this by counting the zeros that we have. So we have 3 zeros, so it's 10 cubed. So here, guys, 100, there's 2 zeros, so it's going to be 10 to the power of 2. But we all know that 100 is 10 times 10, isn't it? So that's why it's 10 squared. Now this one, we only have one lot of 10s, so it's just 10 to the power of 1. Okay, because there's only 1 0 as well. And 1 here, there's no zeros here. So it's simply going to be 10 to the power of 0 because there's no zeros. And remember, anything to the power of 0 is 1. Now look at these ones. This one is 0.1. So these are getting bigger, whereas these are getting smaller, isn't it? So 0.1 is 10 to the power of negative 1. Okay? Because 10 to the power of negative 1, guys, it's 1 over 10. Yeah, if we write it in an index form. So 0.1 divided by 10 will be 10 to the power of negative 1. So, I don't know, that's something you might want to remember. Or you can ask yourself, how many zeros are here? There's 1 0, so therefore you can see that it's 10 to the power of negative 1. But so it must be negative this time. This one, there's 2 zeros, so it's 10 to the power of negative 2. Here, 3 zeros, 10 to the power of negative 3, 4 zeros, 10 to the power of negative 4. That's the pattern, so you can kind of see. Now another way you can kind of see it is, see here, you can just count how many numbers after the decimal point in this case, but just trying to focus on how many zeros there are. Question 3. Write 275 in scientific notation. Now remember the two main conditions of scientific notation form. The first thing is that the number in front, the a, must be in between 1 and 10, and the power, 10 to the power of something, that something must be an integer. So first of all, 275, I can write 275 like this, can't I? I've just kind of like expanded it out. So 275, if I put the decimal right there, how would I get back to the original spot? I simply have to multiply by 10, don't I? So we know that 27.5 times 10 is 275. Now another thing, I'm going to put the decimal there now, like this, 2.75, which means I've got to multiply an extra lot of 10. Yeah, because 2.75 times 100 is also 275. So the more decimal places you move to the left, the extra 10s you have to include on over here. So, guys, first of all, look at this number. Is this number in between 1 and 10? Yes, it is, right? So therefore, we don't have to go any further with that. And how many 10s are here? Remember in the very previous question we've done this? 100 is 10 to the power of 2, isn't it? Because there's 2 zeros. So in scientific notation, this would be written as 2.75 times 10 squared. Now another way I'd do it is 275. Because we want the decimal always in front of the first number there. We always want the decimal in front of the first number because then it makes the whole number, that whole entire number, become in between 1 and 10. So I put the decimal there, but remember, the original decimal was there because if the decimal's there, it's a whole number, isn't it? If I don't have the decimal there, if the decimal there, it's exactly the same as 275. So if I put the decimal there, what do I have to do to get back to the original spot? I just multiply 1, 2 lots of 10s. So we do 2 like that, 10 to the power of 2. So that's another way you can do it. You can just use your fingers and count how many extra places we have to go. Question 4. Write this one. That's quite a big number, isn't it, in scientific notation. So what I'm going to do is write like this first. So see how there's 4 zeros here? I've only put 3 zeros here and I just kind of separate out that 10 times 10. So if I have 2 zeros here, I have 100. If I have 1 zero, I have 1,000. If I have no zeros, I have 10,000. So basically I've separated all the zeros with the 345. So 345 times 10,000, we know that's that, isn't it? But I'm going to go further. I'm going to put the decimal there now. And that means I'm going to include another lot of zeros, or another lot of 10 basically. And because remember guys, I always want the decimal in front of the first number because that will make the first number be in between 1 and 10. So I'm going to move the decimal one more place to the left, so that means I've got to multiply another 10 onto the list. So how many zeros? So now this is between 1 and 10, right? And now here, 1, 2, 3, 4, 5, 6, lots of zeros. So it's 10 to the power 6. And that would be the scientific notation form. And again, if we put the decimal there, we have to move 1, 2, 3, 4, 5, 6 places to the right to go back to the original spot, right? That's why it's 10 to the power 6. Make sense, guys? So try to find your own way of making this sound a lot easier. Question 5, write this one in scientific notation. Now, this time is a very small number. Remember guys, we want the decimal to go in front of the first number that's not 0, because if I put it in front of 0, it won't be in between 1 and 10. So what I'm going to do guys is put the decimal to the right by 1. That means we're dividing by 10, because that number divided by 10 will move the decimal to the left by 1, which will go back to the original number, isn't it? So if I go another place to the right, so 4.186, that means I've got to include another lot of 10, so it becomes 100 now. Now, this number here is in between 1 and 10, isn't it? So now we don't have to do any further. This one, 10, 100, is 10 to the power of 2, isn't it? But because we're dividing, okay, so I've just replaced the 100 with 10 squared. But because we're dividing, we don't like to write division in scientific notation. We always want to keep it as multiply. So if I change the division to multiply, I have to change the 2 to a negative as well. Okay, so because if it's like 4.186 divided by 10 squared, that would be the same as 4.186 over 10 squared, isn't it? Which is essentially 4.186 times 1 over 10 squared, right? Now this one, if I change it to index form, it will become 10 to the power of negative 2. So that's why I write it like that. So, but you should just know, if we change the division sign to multiplication, you switch the powers, the signs of the powers around. Question 6. Write this one in scientific notation. Now, I'm going to move the decimal to the right by 1, so make sure you divide by 10. Right by 1 again, divide by 100. So add an extra 0. Divide by 1 again, add an extra 0. So, basically, I'm moving the decimal over to the right 1 by 1, but whenever I do that, I have to add an extra 0 to this 100 list. So, therefore, this one, as you can see, it's in between 1 and 10, so we can stop. This one, 1,000, is 10 to the power of 3, isn't it? But we always want multiplication. So if I change the division to multiply, the 3 becomes negative 3. So you just switch that around. 7, 20,000. I'm going to remove 1 0. So I'm just going to make it 2,000, but make sure we multiply by 10. 2,000 times 10 is 20,000. I'm going to remove 1 0 from this one as well, but that means I'm going to add an extra 0 here. Remove another 0, add an extra 0 here. 2. If I remove another 0, it's 10,000. But you can probably, guys, go to this step straight away, because we know that 20,000 is 2 times 10,000, isn't it? So, as you can see, 2 is in between 1 and 10. And how many zeros here? 4. So we can just write 2 times 10 to the power of 4. Question 7. Write this one in scientific notation correcting to 2 significant figures. Okay, so it says 2 significant figures, which means we can once we put it in scientific notation, the number in front of the 10 to the power of something, we have to round it off. But we'll do that at the end. First of all, 4.437000 is the same as 43700 times 10. I'm just removing 1 0. And then if I do that again, keep moving the decimal, and again like that. So I'm not going to explain this process all the time, because this step is just these steps are just there to guide you, but you can, guys, probably go to this step straight away. Because remember, guys, we always want, I'm just going to write this number again, we always want the decimal there in front of the first non-zero number, because that would make this number between 1 and 10. So to go back to the original spot, I have to multiply 1, 2, 3, 4, 5 lots of 10s. So we can say this 4.37 times, see how there's 1, 2, 3, 4, 5 zeros, is 100,000. That's what you can do. And therefore, as I said, there's 5 lots of 10s, so it's 10 to the power of 5. And as you can see, guys, this one to 2 significant figures is 4.4. We make sure you start from the first number, 1, 2. And because it's a 7, round the 3 up to 4. Question 8. Write this number in scientific notation correcting to 2 significant figures. I'm going to do the exact same thing. So if I move the decimal to the right by 1, I have to make sure to divide by 10 by 1. And then if I move the decimal again to the right by 1, I divide by 100. move it to the right by 1, that means we're dividing by 1,000. And as you can see, it's in between 1 and 10. And then we know that 1,000 is 10 cubed. And also, can you see that I've just rounded this off to two significant figures as well? Just do that once you've found that number. And then change the division to multiplication and make sure you change the 3 to a negative. And again here, guys, we want the decimal there, don't we? Because we want it in front of the first non-zero number. To go back to the original spot, we go 1, 2, 3 places backwards. That's why it's 10 to the power of negative 3, because we're going backwards, we do negative 3. That's another way you can look at it. 9, write this one in as a decimal number. So, this one, if I multiply 10 to the power of 5, which is 100,000, and if I multiply by 10, I get 12.3, and then one of the zeros reduced. I'm just going to keep going. Keep going. And that's the answer. But you can guys probably go straight to this step. As long as you know that 10 to the power of 5 is 100,000, just move, see 1.23, see 100,000 has 5 lots of 10s. So we move 1, 2, 3, 4, 5 places. And all these missing spaces, just include all the zeros. And now you can get rid of that decimal because it's now here. So it's 1, 2, 3, 0, 0, 0. Okay, I like to use these little sort of wavy stuff to guide me. It always helps. Let's do another one. Question 10. Write 4.03 times 10 to the power of negative 3 as a decimal number. So again, if I divide, see, 10 to the power of negative 3 means we're dividing by 10 to the power of positive 3, aren't we? So what we do is we divide by 1,000 because we know that 10 to the power of 3 is 1,000, right? So if I divide 4.03 by 1,000, if I divide by 110, I move my decimal to the left by 1, you can see. If I divide by another lot of 10, move the decimal to the left by 1 again. If I divide by 10, my last lot of 10, I move the decimal 1 place to the left again, and that will be your final answer. You keep going until there's nothing left on the denominator. Now, as I said, guys, another way you could look at it is, see, that's the decimal. But we want to see how it's 10 to the power of negative 3. We want to go back by 3 places. So we go 1, 2, 3. So now that decimal's gone because the decimal will now be here. So we include all the remaining spaces with zeros. So we have 0.00403, which is exactly what we have there. So if you get into the hang of this, guys, you can actually go straight to the answer without going through all this big processes, but trying to find the right way for you. Okay, so that was some scientific notation.